Welcome to the Fire Sprinkler Podcast with Chris and Logan.
Life doesn't stop at 30 below, and neither does LFP. Introducing Tyco LFP Antfreeze Plus, the first UL-listed antifreeze for wet pipe systems to reach a minimum use temperature of minus 32 degrees Celsius. Now servicing a larger geographic footprint, LFP Antfreeze Plus reaches into the coldest North American regions. Listed for residential, commercial, and some storage applications, LFP Antfreeze Plus is compatible with CPVC piping components and can support large volumes of up to 500 gallons. Available in US and Canada. To learn more, visit www.tyco-fire/LFP.
Like and subscribe.
Hey everybody, thanks for tuning into this episode of the Fire Sprinkler Podcast, video episode of the Fire Sprinkler Podcast. I have Bob Cordell on from Tyco, and we are going to talk about the new LFP Antfreeze Plus, which is a new and improved version of the antifreeze, lower temperatures. Bob, how's it going today?
I'm doing good, Chris. How are you doing?
It's still too early to tell, but so far so good. Finally here in Canada, southwestern Ontario, getting into the colder months, so it's perfect to have you on at this point. The service calls in the past 3 weeks have been insane, not as insane as Texas. I'm sure you've been paying attention to everything down there, but
yeah, it's certainly a timely conversation. I think freeze protection is a conversation everybody's having right now. So yeah, thanks for having me on today.
Yeah, absolutely. So why don't, I think everybody knows you by now. I've had you on before, but why don't you kind of start by introducing yourself and what you do with Tyco?
Sure, yeah. Right, Johnson Controls, selling Tyco fire protection products. That's right.
Yes.
My name is Bob Cordell. I'm the global product manager here for special application and commercial sprinklers, and I also manage our antifreeze product line, which we're happy to announce now that we have more than one product in that product line with the launch of our new LFP Antfreeze Plus. So yeah, in addition to new products, product managers here manage the day-to-day ins and outs of the product line. So everything from new product development to interfacing with the listing agencies and laboratories, and I sit on a couple NFPA committees and things like that. So yeah, I've been here for about 5 years, managing the product line. Before that, I spent some time at FM Global, and before that, I was actually here designing fire sprinklers. So that's a bit of my background.
A lot of experience in the industry, regardless.
Yeah, jumped around a little bit.
That's awesome. And essentially now, by the sounds of it, you get to do what I love to do and just talk sprinkler all day, every day, and kind of improve the industry any way you can, right?
Yeah, product management is great for that because my job is to go out and talk with people like yourself and contractors, designers, end users. We have a huge business development and sales team that really holds those relationships directly, but trying to find out what those needs are and build those into product pipelines and get things on a roadmap for the future that the industry needs now and will need in the future. So it's very interesting. If you love fire sprinklers, being a product manager in a fire sprinkler business is kind of the end all be all, because you get to really set the direction for the product line. It's a lot of fun.
Yeah, hosting a podcast is also a pretty good thing to do if you like talking sprinkler. I mean,
yeah,
it works out for me. So the LFP Antfreeze Plus is the new line that you guys have come out with. What's the difference between this model, this product, and the recent one that you guys put out about 1.5 years, 2 years ago?
Right. So the big difference here is that we've drastically dropped the temperature, the minimum use temperature that you can use this product in. Before, our minimum use temperature for the LFP product was about minus 10 degrees Fahrenheit. Now we've dropped to minus 20 degrees Fahrenheit or minus 32 degrees C. So it's a substantial drop. And for us, the big reason that we did that was because we realized that a large portion of the market geographically couldn't use the minus 10 product. We need to go even lower to go further north. So, especially for your region, I think there may have been some applications for the minus 10 product up there, especially if you have a partially heated building or it's heated seasonally or something like that. But if you want full year freeze protection, in the coldest climates, you need something that goes well below where we were at before. So that's really why we launched a new product, was, serve the market that didn't have a product. And also, we're facing a sunset date for unlisted antifreezes to be removed from existing systems. End of 2022, you're likely going to see a lot of jurisdictions require those systems be retrofitted with something that's listed. So we knew, that the market, it wasn't just us trying to put something out there to sell it. It was something that the fire protection community actually really, really needed.
Right.
So we're really happy about this launch.
Yeah, because there's a lot that market themselves out there as approved, but approved isn't listed. I believe they're starting to switch the wording around a little bit, but it's there's other products out there that are commonly used in my area, at least, and I know it's used in the States, and it's advertised as an approved antifreeze, but essentially the approval is I say it's approved, so it's good to go.
Yeah, so there's really one standard. There's one test standard out there for listing your antifreeze, and that's the UL 2901 standard that came out in 2018, that they had been working on since since the requirement went in around 2000, the early teens. I think it was 2011, 2009 or 2011. The requirement went in to create listed antifreezes, right? So UL set to task in developing that. So I think we have our two listed antifreeze products. There's one other competitor out there with a listed product. Other than that, there's nothing. So if you're meeting NFPA 13 or 25, the requirements have a listed antifreeze. This is the product of choice.
So they made the requirement to have a listed antifreeze back in, like you said, I think it was 2011 or 2012 is what's kicking in the back of my head. It took them until 2018, and I think that's when you guys came out with the original antifreeze. Did you guys have this thing created back in 2015, but didn't have anything to base the listing on?
It was in development around that time frame, but the listing criteria, so the actual tests within 2901 weren't fully developed. So UL had their own, they create an ANSI-based standard. So it's a consensus-based standard that has to go out for multiple rounds of review. And they were creating all these tests from scratch. So we did have an open program while we were developing the product with UL to run through some of the testing that they were kind of experimenting with. So we had a basis of understanding how we would perform when it eventually got published, when the standard eventually got published. So yeah, we were in development, but obviously we weren't able to attain a listing until the standard was in the final form. And it did just so happen that we were able to time up when we were able to launch and commercialize it with when the standard was published. So yeah.
So you guys are at is it minus 20 or minus 25 degrees Fahrenheit, minus 32 degrees Celsius? That's the one that sticks in my head being Canadian.
Yep.
How much of a challenge was it to go from your existing LFP product to this one? Like how much additional? Well, I mean, obviously 2 years worth of work was involved in it, but
about that.
Was it a complete breakdown and build up from the ground up on the formula?
No, actually, there were a lot of challenges, and I can speak to a couple of them. There are 21 tests within that UL 2901 standard, and each one of them is a challenge anytime you create a new formula. But we didn't have to start from scratch. Our existing formula was able to be, I'd say, modified slightly in order to get the lower freeze point. So it's basically the same constituent materials in the formula. We know that the formula is proven. It's had a really good track record while it's been in the field for the last couple of years. We didn't want to change it drastically, quite honestly. We wanted to keep it as similar as we could. So we tried to develop it as similarly to the existing formula as possible. The challenges are in balancing some of the physical properties that are inherent to the material or the formula with the testing that you have to undergo through the laboratory. So the challenge is trying to take your best guess at what formula might work across all 21 of these tests before you actually go attempt them, because it gets quite expensive. Within there are 4 fire tests that I would say are probably the most challenging part of the examination, and you need to run them at a minimum and a maximum nozzle pressure. And when you do maximum nozzle pressure with fire sprinklers, you get smaller droplets. And when you get smaller droplets of water, you get more cooling. The challenge when you're distributing something other than water is to make sure that you still get cooling when you have very small droplets. Right. Because it's not actually water. We want to make sure that it performs similar to water in terms of the heat release rate. So those are the big challenges. And we have a couple methods that we can employ internally in order to model some of that stuff before we go test it. But that's the big challenge. And then the secondary big challenge is there are, I think, 6 environmental and corrosion tests that you have to undergo to achieve a listing. And UL, again, is trying to ensure that it doesn't perform worse than water, essentially, for, in terms of its compatibility with materials and things like that. I want to make sure that it doesn't break down any of the materials that will ever come in contact, like CPVC for fire protection or black steel pipe or anything like that. You want to make sure that it remains consistent material and has no interaction. So trying to take your best guess at what formula will pass all those tests, because if you fail a corrosion test, a lot of them are 90-day tests. You have to start over. And that's another 3 months added to your development time.
Right. When you say take your best guess, I'm assuming you're not just throwing a dart at the wall. There's probably a lot of behind the scenes stuff with taking your best guess, but I'm sure it's not a cheap process. So you want to make sure you get it right the first time. You talked a little bit about kind of the design parameters that are the benefits and the negatives. Obviously, with the smaller droplet size and it not being water, you want to make sure we don't run into the same problems as we did with people mixing their own antifreeze with glycol, where you got the fireball. So that's obviously probably the first thing you want to make sure of. But what would you say is the main portion, the main pitch that you have for this product? Like, where are people going to be using it? What's the intended and best practice for the product?
Yeah, so great question. I think anytime you are going below 40 degrees Fahrenheit in terms of being able to maintain your the space that your sprinkler is in or your sprinkler piping is in, you have to employ some sort of freeze protection. So antifreeze might not always be the best choice. There are some other options out there. Dry sprinklers themselves, if you're able to keep the piping conditioned. Dry systems, you can use heat tracing. There are other methods that you can use. However, antifreeze provides the advantage of a set freeze point where we know it's not going to freeze. Some of those other applications, you need to take additional steps, right? For dry systems with your air maintenance devices and things like that. You have other pieces of equipment. For antifreeze, the reliability factor goes up substantially compared to some of the other systems that have a lot of other different components. So especially if you already have an antifreeze system. So if there's antifreeze systems out there that do have an unlisted formula in there, it was pre-mixed, it was unlisted, nobody knows what it is, it's going to be a lot easier for you to retrofit with a listed antifreeze than do a dry conversion.
Yes,
so
absolutely.
Yeah. So in addition to new systems where, if you don't want to go to the expense of a dry system, and once you add in your dry pipe valve, your air maintenance device, some of the other factors, you are going to usually end up more expensive than a wet system with antifreeze. In addition to that, with the dry system, you're often going to have to pay a design area penalty for your water and have to do water delivery time calculations. So there are some more complicating factors with the dry system. Not to say dry systems don't have their place, they certainly do. There are a lot of applications where a dry system will work and be better than an antifreeze system, quite honestly. I mean, but where you want a high degree of reliability and you want to know that your system will not freeze down to a certain temperature, an antifreeze system would be advisable. The other thing is that our product doesn't freeze solid once you go below minus 32F. It's just that, or sorry, minus 32C, minus 25F, minus 32C. Once you go below that, you're outside of the minimum use temperature range,
right?
Meaning that the product may start to crystallize a little bit in the system, but it's not going to freeze solid. So you have a little bit of wiggle room there. So I see that as an advantage. The other thing, in terms of where you would use it, I think you asked where you would use it. Geographically, it's really up to the designer or the engineer of record on the job to kind of take everything into consideration. Is the piping insulated? Is it heated part of the year? What's the minimum and maximum temperature that you're going to be exposed to? There are some tools out there in order to decide whether you would need our minus 10 product or a minus 25 degrees Fahrenheit product. NFPA 13 in 2022, section A.9 in the appendices, section A9122. That's where you're going to have the isothermal lines map in the next version of NFPA 13. So you can use the isothermal lines map in order to determine where you are geographically and what your low mean temperature may be. Also, there's some additional tools out there like the USDA map and NOAA. They each have maps with low mean temperatures. So there are going to be some places where when you get really, really far north, you're beyond even the minimum use temperature that we have, minus 32. So, there's some tools out there, but I would say for the most part, you're going to be able to use it in almost all of the continental United States, and most of the southern parts of Canada, the minus 32 will work for you.
Right. And another good benefit of it as well is at minus 32 degrees Celsius, you could utilize this in a sort of a tail end type of system for loading docks, garbage rooms in apartment buildings, entrances to parking garages, those few lines at the entrance where those are the ones that typically freeze up with wet and dry systems if they're not sloped properly. This is where I see this being a big sales pitch there. I understand there are some limitations in the design once you go to a certain size of the system. Can you talk about that a little bit?
Yeah, there's a couple things as far as limitations. First, UL, as part of the listing of any UL listed antifreeze, has set volume limitations on the size of systems that you can have with antifreeze in it. So for NFPA 13D and 13R applications, you're limited to a maximum of 500 gallons per riser.
Right.
And for NFPA 13 light hazard, you're limited to 200 gallons per riser using wet system design rules. And you can go up to 500 gallons per riser. And at that point, you have to use dry design rules. So you're employing the 30% design penalty.
Right. Okay.
For NFPA 13 OH 1 and 2, you're limited to 40 gallons per riser. And for any storage applications, you're also limited to 40 gallons per riser. So this has all changed in about the last year. You were previously allowed unlimited volumes for 13D and 13R, and you were limited to 40 gallons for NFPA 13 light hazard. So what caused the jump from 40 gallons to now up to 500 for light hazard criteria was that UL went back and they did a lot of research themselves in terms of, what the real allowable limit could be. So I would expect that at some point in the future, we would also see the OH and storage rules be expanded. It's really not dependent on the manufacturer. We can't do anything at this point. It's in the listing agency's hand. And really, they're just trying to be risk averse when it comes to, how much antifreeze it has to get discharged from a system before water arrives. So additionally, there are some other limitations that you need to think about when you're using antifreeze. because antifreeze has different physical properties than water, you need to think about two real main things. Using an adjusted K factor. So, and then the other thing is friction loss, and we'll get to that in a second.
Sure.
Our data sheet has some formulas in it for adjusting your K factor. Essentially, you would follow the formula and input the actual nominal K factor of the sprinkler that's in your most remote area. And the K factor adjustment will effectively reduce that K factor. So if you're putting in a 5.6 K head, it might tell you to use the K factor in your hydraulic design of 5.2. I'm just pulling that out.
Sure.
But it's always going to be lower. So effectively what the K factor reduction is doing is artificially getting you to add more pressure into the system to drive the thicker liquid through.
Sure.
The other factor that you need to take into account is that because it's got a higher density than water, you need to use the Darcy-Weisbach formula for friction loss with physical properties other than water. So we've actually done something really good this time around with this data sheet. We actually put physical property curves. So there's a curve, a temperature dependent curve for specific gravity and viscosity in our data sheet. When you're designing with our liquid, you don't always have to design it as if you're installing it at -25. If you can make an argument that you're never going to go below -20F or -15F, you can select the physical properties at that point and use that to calculate your friction loss. And the net effect on your riser pressure and any pipe upsizing that you need to do in order to make those pressures work for your system will be reduced if you use that. So we're really happy we were able to get those physical property curves in there, and we're working on getting that adjusted for our original product as well. There's one other thing that you need to think about when you're designing with our product, and that's the minimum head pressure.
Right.
So when we went through development with this product, it was the lowest minimum use temperature product that UL had seen, and as an effect of that, the lowest the highest viscosity at the minimum use temperature of anything they had reviewed so far. Certainly a higher viscosity than our existing product. So the question was raised of how will this perform in terms of distribution? So shifting away from the things we just talked about, which are adjusting your K factor and friction loss, once it gets to the nozzle at a 7 or 10 PSI, somewhere that people typically design for commercial occupancies, how does it perform? And we looked at it and we thought that along with UL, that we should have a little bit higher of a nozzle pressure in order to achieve really good distribution out of the head. So there are some requirements. If you're out there designing with the system, make sure you pay specific attention to our data sheet, because you'll want to follow the minimum nozzle pressure requirement in addition to the adjustment of the K factor and the friction loss calculation. And by the way, Chris, most people, if you're designing with an unlisted antifreeze right now, something pre-mixed, you should probably be doing an adjustment on your K factor and a friction loss calculation with that antifreeze. So that's nothing new. But the addition of the minimum head pressure, and it should be pretty easy, pretty straightforward if you're using design software.
Yep.
After you've done your friction loss and your K factor adjustment, you can then go check, am I at or above the minimum pressure required per the data sheet? And if you're already above that minimum pressure, you don't need to do anything. If you're below that minimum pressure, most design software, certainly our SprintCAD software, allows you to go in and put and demand a minimum head pressure at your most remote nozzle, and then you can back calculate from there.
I was going to ask you if the SprintCAD software was going to have an update released where it essentially performs the is it eventually going to have where you put the temperature into the SprintCAD software and it performs the calculations based off of the viscosity of the liquid, friction loss required, pressure, stuff like that?
That's a good question. That's a good question. Yeah. We certainly could develop that capability. We don't have it in there now. It should be pretty straightforward right now. If you have SprintCAD up and you have our data sheet up, you can easily just go to the physical properties, and there's a section in SprintCAD where you can open up the Darcy-Weisbach formula and put in the specific gravity and the viscosity, and it'll calculate it for you. So
just for
that's a good addition for the future.
Yeah, and if you do, you make sure you call it the Chris Logan edition, and or the FSP,
Sure.
the FSP add-on, and a couple pennies every version you sell. That's no problem. I'm not greedy.
You want those royalties, huh?
That's right. Yeah. Awesome. And it is like I'm very confident we mentioned it before, but it is CPVC approved. It is listed to be used with all the CPVC products, which is
Correct.
good because there is a lot of antifreeze products being installed in residential NFPA 13D homes. If you're going with I believe you said you're good up to 250 gallons, or is it 500 gallons for 13R and 13D?
It's 500 gallons for those.
500
and yeah,
gallons.
we are compatible with CPVC. It's part of the UL listing. And we also, it's got the FBC compatibility.
Yes.
Along with our BlazeMaster CPVC product that we sell.
Yeah, and if you're installing a residential 13D system that's 500 gallons, that's a massive house. So
yeah,
I mean, good for you.
Yeah, for the most part, our design recommendation is to try to stay below the 200 as much as possible, even for some of those applications where you're allowed to go up to 500, just because once you have that size of a system on a single riser, you're really going to be impeded by some of the friction loss aspects. Yeah. And this goes for any antifreeze really. The larger the system, the more you're trying to push through, the bigger impact that friction loss is going to have, and more impact that's going to have on things like your hardware and your pipe size, and if you need a pump and things like that. And especially that goes for the 13 light hazard stuff where you want to stay below the 200 so you don't have to pay the design penalty.
So I know you guys keep pretty tight-lipped about stuff like this, but I'm going to ask anyways because that's the nature of the beast. Do you guys have intentions on going lower with the temperatures? Is there anything else out there that you can give me as a kind of first to release thing?
Yeah, I don't have anything else to announce today, if that's the question. But Chris, we're going to keep innovating in this space, and for both antifreeze and freeze protection in general, this is a big deal for fire protection. You saw what happened in Texas last week, right? And if you're listening to this in the future on the podcast, there's a big freeze up in Texas, a lot of impact to fire sprinkler systems. So yes. It's certainly an area we're going to continue to innovate in. We're kind of getting our feet under us, and I'd say maybe we're even beyond that. We've moved past walking now. We're jogging in this antifreeze space. And I think, going lower is a good question. I think we'd like to see how much of the market this minus 32 product or minus 32C product serves, right? Before really jumping into that space. It's something we're looking at, but it's not something that we're going to launch a product, in a couple months or something. But this product is UL listed for use in United States and Canada. You can go on the UL product IQ page and check all the criteria that we were discussing. I think it covers a lot of the market. So I'm not sure how much lower we'd need to go, but it's something we'll continue to look at.
Well, the best thing I liked about that answer that you said is essentially see what the market says. There are other manufacturers out there that are trying to reinvent things that have been around for 100 years. If it's not broke, don't fix it. The fire protection industry is typically pretty stubborn when it comes to new things. So that was a really good thing to say. See what the market says. If they want something lower, we'll go lower. But otherwise, what's the point in changing something that's not broken?
You're right. I mean, that's what's brought us to this point today where we're launching this product. We listened to the market. We knew that there was a big need out there, and that there were people that were stuck in a spot where they have something that's installed that is going to have to get removed by the end of next year, and they have nothing to replace it with. Right. So really, we will definitely let the market guide us in terms of what comes next for antifreeze and freeze protection in general. Yeah.
Awesome, Bob. It's always great talking to you on the podcast and off the podcast. Hopefully soon we can get this COVID-19 thing cleaned up and we can get back to the trade shows and we can shake hands and have a beverage here at some point in the future.
Looking forward to it, Chris. Thanks for having me on today. Really great conversation. I always appreciate it.
Absolutely. Thanks for coming on.
Hey everyone, this episode of the Fire Sprinkler Podcast is done. If you liked this episode, leave a review, comment, or hop over to my social media pages and let me know. Just search Fire Sprinkler Podcast on Facebook, Twitter, Instagram, or LinkedIn. Don't forget to hashtag Fire Sprinkler Podcast and anything you think I should know about or see. If you have any suggestions for future episodes of the Fire Sprinkler Podcast, email info@firesprinklerpodcast.com. Thanks for listening. We'll see you next time. Take care.